Okay, welcome to Monday's lesson. We are on lesson 4, scale drawings, and that's found on page 575 of your textbook. To start off today, just reviewing the essential question, how does geometry help us describe real-world objects? Some of the vocabulary we're going to be working with today is a scale drawing, a scale model, a scale, and scale factor. And what we're going to be dealing with today is how do we make pictures or models of things that are too big to deal with in person, like a blueprint if you're building a house, or a model train, or something that we want to be able to touch and feel and measure without the actual object. So if you take a look at the real world link, we've got a bedroom here, and this student measured the dimensions, measured everything, and in order for a blueprint drawing to be accurate, everything has to be to scale. That means that in the drawing, notice that the rug and the bed look to be about the same size. In real life, they should also be about the same size, so that everything is in proportion to the other things. So down here, it says measure the length of 3 objects in the room and record each length to the nearest half a foot in the table below. So we're going to do this just by counting some units. So for the bed, notice it's 1, 2, 3, 4, 5, 6 units in length. And for the nightstand, let's do the length this way. Nightstand is 1, 2 units. And if we do the dresser, if you count the dresser, that's 1, 2, 3, 4, 5 units. Okay, and then we're going to use this scale. So a scale is kind of like our key. Okay, so 1 unit is equal to 2 feet. So this is kind of like what we're going to do to convert this. So if the bed is 6 units long, 1 unit is 2 feet, so 6 times 2, this is going to come out to be a 12 feet long bed. And that does seem a little too long for actual bed. But our nightstand was 2 units, so that would be 4 feet long. And our dresser is going to be 10 feet. Okay. All right, if you turn the page, we'll get into some vocabulary. Scale drawings and scale models are used to represent objects that are too large or too small to be drawn or built at actual size. The scale gives the ratio. So we want to emphasize that when we talk about a scale, we're looking at a ratio that compares the measurements of the drawing or the model to the measurements of the real object. The measurements on a drawing or model are proportional to the measurements on the actual object. Okay, so off to the side, our scale is our ratio. Whoops. And it's a ratio where we put the map or the drawing on top over the actual. So let's look at example 1. What is the actual distance between Hagerstown and Annapolis? So if you take your ruler, first thing you want to notice is that our scale down here is saying that 1 centimeter is 24 miles. Okay, so that's our scale. 1 centimeter is to 24 miles. So now we want to measure as best we can from Hagerstown to Annapolis. Okay, now if you go just the way the crow flies, not following the road, you see that Hagerstown's up here at 0, Annapolis is at 4 centimeters. So assuming there's a road that goes between here, I guess that's the true distance, is 4 centimeters. So watch what we're going to do. We're going to set up a proportion. And we're going to say 1 centimeter on the map is to 24 miles in real life. So 4 centimeters on the map is equal to what? Okay, so if you review, it's going to look like this. 1 is to 24, as 4 is to x. And we've solved proportions like this all year long, so we do cross products. 1 times x is x. 24 times 4 is 96. And notice that's exactly what they get, 96 miles. Okay, so please use the same scale that we did up here. 1 centimeter is to 24 miles. And you are going to use your ruler to go from Clarksville to Little Rock. Set up a proportion down here and solve it. When your video is over, please show all of the notes and the work that I've told you to do on the video to Mr. Sears, and he will initial and star it. So please pause the video and do your calculation. Okay. So I look here, Clarksville to Little Rock came out to be 4 centimeters, so it's going to be the same exact calculation as before. So it should have come out to be 96 miles. Let's go to the top of the next page. A graphic artist is creating an advertisement for this cell phone. If she uses a scale of 5 inches equals 1 inch, what is the length of the cell phone on the advertisement? Okay, so 5 inches, 5 inches to 1 inch. That means 5 inches on the drawing is to 1 inch in real life. Okay, so in the advertisement, if it's 5 inches, it's going to be 1 inch in actuality. So write a proportion using a scale. Let A represent the length of the advertisement in the cell phone. So our actual measurement up here is 4 inches, so we do 5 to 1 as x is to 4, and we do cross products. So the length of the cell phone on the advertisement actually comes out to be 20 inches long. Okay, so this is not a great example because to me this is unclear that this is the actual phone. So this would be like if we were making a giant flyer. If we made a huge flyer of this phone, the actual phone, the real phone on the flyer is going to be much bigger. Okay, so let's try Got It question B. A scooter is 3.5 feet long. Find the length of a model of the scooter if the scale is 1 inch is to 3/4 feet. And if you have trouble setting up your proportion, these units are going to help you because we do inch model over actual. Whoops, that should be 3/4 equals, if you look over here, a scooter is 3.5 feet long. Does it make sense that we would want to put 3.5 feet up here or in the denominator? Well, it should be in the denominator because we want the units to be the same. We also know that it's saying find the length of the scale model. So our x should be in the position of where we're finding the models. So it's always model over actual or map over actual. So we do cross products and we get 3.5 equals 0.75x. And then when you divide both sides by 0.75, x comes out to be 4.6 repeating, which we don't ever want to leave 0.6 repeating like that because we know that that's exactly 4 2/3 inches. Okay. All right, now we're going to take our scale and write it as a scale factor. A scale written as a ratio without units in simplest form is called a scale factor. Okay, so if we start with our scale of 1 inch is to 6 feet, if we simplify it by reducing the units, we can get our scale factor. Now to reduce the units, we can't just cross off inch and feet. We first have to do a little bit of conversion. So we're going to leave 1 inch the same, but you see that 6 feet is the same as 72 inches because there's 12 inches in a foot. Now you can cancel the inches. We say our scale factor is 1 to 62. Or I'm sorry, 72. So what does this mean? So over here, What does scale factor mean? If we have a model that is 1 inch is to 6 feet, that means that our ratio between our model and our actual is 1 to 72. That means the actual is 72 times larger than the model. The scale factor is telling us how many times larger or how many times smaller it is. We can't look at 1 inches to 6 feet and say, oh, it's 6 times larger, because we're dealing with inch and feet. But when we convert it all to the same units and those cancel off, that's where we can pull out that multiplication factor. Okay, so what is the scale factor of a model car if it's 1 inch is to 2 feet? Well, we first have to convert it all to inches. 2 feet is 24 inches. Our inches will cancel. Our scale factor is 1 to 24. Okay, turn the page, please. Okay, let's go down here at 1, 2, and 3. I'd like you to pause the video and set up and solve 1, 2, and 3. When you're finished, I want you to hit play and see if you solve these correctly. So on a map, the distance from Akron to Cleveland measures 2 centimeters. What is the actual distance if the scale of the map is that 1 centimeter is 30 kilometers? So that means 2 centimeters is to what? Well, this one I don't even have to do a proportion with because I see that we're just doubling it. So this comes out to be 60 kilometers. Number 2, an engineer makes a model of a bridge using a scale that 1 inch is to 3 yards. The length of the actual bridge is 50 yards. What is the length of the model? Remember, we always put model on top, actual on the bottom. So this is going to be 50 yards on the bottom, x on top. I'm going to cross multiply. 1 times 50 is 50. 3 times x is 3x. And then I divide both sides by 3 to get x is equal to 16 2/3 inch. And there comes the 2/3 again because the calculator gave me an answer of 16.6 repeating, and we want to turn it to 2/3. The next one, Julie is constructing a scale model of her room. The rectangular room is 10 1/4 by 8. If 1 inch is 2 feet, what is the scale factor and the actual area of the room? Okay, so I'm going to do the scale factor first. So if 1 inch is to 2 feet, to turn this into a scale factor, I need to change them all into inches. So 2 feet is 24 inches. So our scale factor is 1 to 24. That means our room is 24 times larger than this. Okay, so we can do this problem in a couple ways. Using our scale factor of 10.25 inches and 8, if I do length times width, I get 82 square inches. I know that my actual room is going to be 24 times larger than this. So I can do 82 times 24. And that comes out to be 1,968 square inches. Okay, but that's kind of a weird answer because really I probably want the answer into something more useful, a square inch and a square feet. So if I look at a square foot, 1 foot by 1 foot, there are 12 inches in a foot both ways. So do you see that there are 144 square inches in square inches in 1 square foot? So if I divide this by 144, I get my solution of, oops, something didn't work out. Should be, I got an answer of 13.6 repeating, but I don't like that answer. Alright, so let's put this on hold for a minute to find the area of this room. Another way I can do this, if this is 8 inches and every inch is 2 feet, isn't this going to be 16 feet in real life? And if we do 10 1/4 by 2, that's going to be 20.5. So then if we just do the area, length times width, we get 328. So I did something wrong. It's not very often that I make a mistake, but I did some calculation wrong in here that I wasn't happy with. So to find the actual area of the room, let's do it this way. We went from our scale, we doubled everything to get our new length and width, and then we found the area. Okay, please now show your work to Mr. Sears so that he can initial right up here, so that he can see that you worked through these problems. And then what you guys are going to do today is your lesson 4 in the assignment guide. And I don't have it right in front of me, but I'll make sure that Mr. Sears has it so that you know exactly what problems you need to do on lesson 4. Thanks, be good, and don't party too hard while I'm gone. Bye.